Continuing on with the chain rule, now we're just going to practice. First one, this is all you. Alright, pause the video, unpause when you're ready to check. Alright, so hopefully you got that f prime of x is x plus 2 over the square root of x squared plus 4x plus 3. How do we get that? Chain rule. Oh, real quick notation thing, sorry. I said find y prime on the notes here, but this is f of x, so we want to find f prime of x. Just a notation thing. Details are important though. Alright, so what do? We do the chain rule, so that we do the derivative of the outside. So I bring 1/2 down, leave the inside the same, subtract 1 from the exponent, so it's negative 1/2, times the derivative of the inside, which is 2x plus 4. Now, just a little bit of simplifying. So I bring this down to the denominator, write it as a square root. There's a common factor of 2 in the numerator, so the 2's reduce, and that's how we get our answer. Nice. Next one, show me you can combine some rules. Here we got a product rule and a chain rule. Pause the video, unpause when you're ready to check. Alright, so here we should end up with y prime equals the quantity x cubed plus 3 to the 5th times the quantity 2x to the 4th plus x minus 2 to the 9th times the quantity 116x to the 6th plus 268x cubed minus 36x squared plus 30. This is also what we call factored form, which will be important in terms of how we write some of our answers on a test or a quiz. Sometimes I'll ask you to do this, other times I'll say don't simplify at all. So it is important that you are able to do both. So how do we get that though? Let's go back up to the top. So we have the product of two quantities, so we have to do the product rule. So let's talk through it. The first times the derivative of the second. So did you see how I color coded these with, yeah, that's quality teaching right there. So the derivative of the second though, we have to do the chain rule. So bring down the 10, so because we do the derivative of the outside times the derivative of the inside. And then plus, now the derivative of the first, where I do the chain rule, derivative of the outside times the derivative of the inside, and then times the second. From here it became simplifying, combining, so we kept this the same. I noticed that I had a quantity of x cubed plus 3 to the 6th and x cubed plus 3 to the 5th. So I'm going to factor that out, x cubed plus 3 to the 5th. I noticed that I had the 2x to the 4th plus x minus 2 to the 9th, 2x to the 4th plus x minus 2 to the 10th, so I factored it out to the 9th. And then I take everything that's left over, distribute, combine like terms, and that's how we get our answer. Alright, try this one. F of x equals the quantity x over x squared plus 1, all to the 5th. Spoiler alert, you can use the quotient rule if you choose, but you don't have to. Pause the video, unpause when you're ready to check. Alright, so here we should end up with negative 5x to the 4th times the quantity x squared minus 1 over the quantity x squared plus 1 to the 6th. Alright, how do we get that? Well, so this is actually a really good example of where you have many options on how you want to approach this problem. I usually just leave it how it is unless I see some way that it's going to simplify before I start doing the derivative. But, for instance, you could have thought of the original problem as f of x equals x to the 5th over x squared plus 1 to the 5th. And so now I would do the quotient rule, and then within the quotient rule I would do the chain rule. As opposed to the way I did the problem, I did the chain rule, and within the chain rule, when I did the derivative of the inside, if you can picture when I was saying that, I was doing air quotes. So when I do the derivative of the inside, then I did the quotient rule. As opposed to, again, in this form, I would do the quotient rule with the chain rule inside the quotient rule. Or you could have written it as f of x equals x to the 5th times x squared plus 1 to the negative 5th. And now I could do a product rule, and then within the product rule, the chain rule. Either way, if I simplify correctly in the end, I should end up with the same result. So again, what I did was chain rule first, so derivative of the outside, bring down 5, subtract 1, and then times the derivative of the inside, but the inside was a quotient, so I did the quotient rule. Bottom, times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Combine like terms in the numerator here. Notice that I have an x squared plus 1 to the 4th, x squared plus 1 squared. So I can combine those into the 6th. And then just write this as, I brought the negative out from this term, so that's how the negative came here, and that became x squared minus 1. You could factor this if you were trying to get it to factored form. That would be acceptable. Alright, so now we're really going to test your knowledge of understanding the chain rule and derivatives and what they represent. So I want you to estimate the derivative or state that it does not exist of the following things: h prime of 1, h prime of 2, and h prime of 3, given that h of x is f of g of x, and here are the graphs for f of x and g of x. So my hint, I'll do this one for you for the first one, and you're going to have to do this for the rest, is that remember h prime of x is actually f prime of g of x times g prime of x. Okay? So that's what you have to think about. This is just letting us know also that we do have a sharp corner here, so the derivative of f of x does not exist at 2. Alright, pause the video and try to find those three. Unpause when you're ready to check. Alright, so here we end up with h prime of 1 is 2. How do we get that? Well, f prime of g of 1 times g prime of 1. G of 1, just look at the g function when x is 1, is up here with a y value of 3. So then this becomes, what is f prime of 3? So that means when x is 3, what is the slope? The slope is negative 2, because the slope of this function is negative 2 at this x value. G prime of 1 is saying when x is 1, what is the slope? Sorry, this is the g function. The slope here is negative 1. So I do negative 2 times negative 1, which is positive 2. H prime of 2 does not exist, and h prime of 3 is negative 2. And we can look at these by showing, okay, g of 2 is 2, and g prime of 2 is negative 1, and so then it becomes f prime of 2 times negative 1, but f prime of 2 does not exist because that's a sharp turn. So what it's asking, what's the slope at this point? We can't tell, so that does not exist. H prime of 3, f prime of g of 3 times g prime of 3, well, what's g of 3? G of 3 is 1, so then this term becomes, what is f prime of 1? F prime of 1 is positive 2, because the slope right here is positive 2, and then g prime of 3, I already know that that is negative 1, so 2 times negative 1 gives me negative 2. Nice work. Any questions? Alright. Maybe later. Well, try this one then. So notice that it's the same thing, except for now h of x is g of f of x as opposed to f of g of x. So pause the video, try this, unpause when you're ready to check. Alright, so here we know h prime of x is g prime of f of x times f prime of x. So h prime of 1 is g prime of f of 1 times f prime of 1. What is f of 1? F of 1 is 2 right here. So then g prime of 2 is, what is the slope? Well, that's negative 1. And then f prime of 1, what is the slope here? That is positive 2. So h prime of 1 is negative 2. Negative 1 times 2 is negative 2. Good. H prime of 2, let's first figure out what is f of 2. F of 2 is 4. And then I'm doing g prime of 4, which I can find, but f prime of 2 does not exist. So this does not exist. G prime of f of 3 times f prime of 3. So what is f of 3? F of 3 is 2. So then I have g prime of 2. G prime of 2 is negative 1. And f prime of 3 is negative 2, so negative 1 times negative 2 is 2. There we go. Last one, try h of x equals f of x. Pause the video, unpause when you're ready to check. Alright, so sadly none of these work, so none of these exist, or none of these are differentiable, these values. And let's see, it goes back to h prime of x is f prime of x times f prime of x. So let's first find h prime of 1, that's f prime of f of 1 times f prime of 1. F of 1 is 2, so right here I'm doing the derivative of f at 2, which I know doesn't exist. Alright, h prime of 2, that one fails right away, because f prime of 2, can't do it. H prime of 3, f prime of f of 3 times f prime of 3. F of 3 is also 2, so can't do it. Does not exist. Alright, good work with the chain rule.